Dear students, welcome to the problem solving session on Cauchy integral theorem and Cauchy integral formula part 1. In the first two videos, we learned the basic. We learned what is meant by singular point, simply connected region, multiply connected region, simple closed contour. Next we see what is meant by entire function, Cauchy integral theorem, Cauchy integral formula and Cauchy integral formula for higher derivatives. Let us have a quick recap. If f of z is analytic everywhere, inside and on a simple closed contour C, then integral over C f of z dz is equal to 0. Next, Cauchy integral formula. If f of z is analytic inside and on a simple closed contour C taken in the anti-clockwise direction, if suppose A is a interior point or a point lies inside C, then integral over C f of z divided by z minus a dz is 2 pi I into f of a. Next we see Cauchy integral formula for derivatives. Integral over C f of z divided by z minus a whole power n plus 1 dz is equal to 2 pi I divided by n factorial into nth derivative of f of z, substitute by the value z equal to a. Now we can see the typed version. Before solving the problems, it is very essential to understand the roadmap for problem solving. For a given question, we have to think which formula I should choose. Cauchy integral theorem, Cauchy integral formula or Cauchy integral formula for higher derivatives. Let us have a clear picture. First we have to deal with denominator. We have to find the singular points and location of the singular point. See, these are all some examples. Now we have to check my singular point first in the given problem and then the given region, and we have to find whether the singular point lies inside the region or outside the region. So we have three subdivisions. First, let us think no singular points lies inside the given region. If none of the singular points are lying inside, then we can use Cauchy integral theorem. By Cauchy integral theorem, if f of z is analytic everywhere inside and on simple closed contour C, then integral over C f of z dz is always 0. Next, if the singular point lies inside my region C, then we have to take the singular point in the denominator and consider the remaining data as f of z in the question. For example, see this problem. Here the region is mod z equal to 2. So z equal to 1 is the singular point which lies inside C. So now I have to take the numerator as f of z. I have to keep the denominator simply as z minus 1. So if the singular point lies inside the region C, then we have to apply Cauchy integral formula. We know the Cauchy integral formula. We can easily use it. Next, my singular point lies inside, but the order of the singular point is more than one, higher order. For example, z minus 3 whole square, z square divided by z plus 2 whole power 4. So if we see the singular points with higher order, then we have to use Cauchy integral formula for derivatives. We know the formula. With this visualization, one can easily choose which formula to be applied to get the solution for the given problem. Hope you understand, students. Now let us go into the problem. Evaluate integral over C e power minus z divided by z minus 2, and the given region is mod z equal to 1. At first, sketch the region. Mod z equal to 1 is simply a circle with center 0, 0 and radius 1. We can easily draw this. Next, step 2, singular points. Go to the question. My denominator is z minus 2. We have to equate the denominator to 0 to find the singular point. So z equal to 2 is the singular point. It is very obvious. Z equal to 2 means the point is 2, 0 in xy plane. It is easy to see that 2, 0 lies outside the circle. Therefore, z equal to 2 is a singular point, lies outside C. Next, step 3. We have to identify the key point. Since z equal to C is a singular point, lies outside C, write the given question as capital I. In step 2, we deals with denominator. Now we are going to deal with numerator. we know that e power minus z is an entire function. It is analytic everywhere. Therefore, we can assume that e power minus z is analytic inside and on the given region C. And when we deal with denominator, z minus 2 is singular point, but it is lying outside the region, so it will not affect the problem. So I can take f of z as e power minus z divided by z minus 2. Already e power minus z is entire function. Here z minus 2 also will not trouble because the singular point lies outside the region. So we can conclude f of z is analytic everywhere inside and on the simple closed contour C. Then by Cauchy integral theorem, integral over C f of z dz is 0. So the answer for this problem is 0. So we write capital I equal to 0. Hope you understand, students. Next, let us do one more problem. I will change only my region. In the previous problem, mod z equal to 1 is the region. In this problem, mod z is equal to 3 is the region. So let us sketch the region with center 0, 0 and then radius 3. We can easily sketch this, and the singular point is also known to us because only the region change in this problem. Therefore, the singular point is z equal to 2. It is nothing but x comma y equal to 2, 0. Here my radius is 3. Therefore, 2, 0 lies inside the circle C. So we conclude z equal to 2 is a singular point, lies inside capital C. Now let us run back to the roadmap. When I check the denominator, the singular point lies inside the C. So I have to apply Cauchy integral formula. Step 3, let us write the key points. Z equal to 2 is singular point, lies inside C, and we assume the given question as capital I. While you check the denominator, 1 by z minus 2 is not analytic because the singular point lies inside C. So I will take only the numerator as f of z. And f of z is analytic inside and on C. Now we have to apply Cauchy integral formula because my singular point lies inside C. Now compare my given question and Cauchy integral formula. F of z is equal to e power minus z. Then the value a is equal to 2. Now applying Cauchy integral formula, we get capital I is equal to 2 pi I into f of 2. Now we have to substitute the value of z equal to 2 in f of z. My f of z is e power minus z. So f of 2 is e power minus 2. You can see the typed version. Therefore, substituting this, we get I is equal to 2 pi I into e power minus 2, or we can rewrite this as 2 pi I divided by e square. Hope you understand, students. So the roadmap is very important. If you remember it, identify the problem and choose the appropriate formula, get the answer. For more clarity, we will summarize example 1 and 2. In both the examples, only the region varies. In example 1, we have mod z equal to 1. And in example 2, we have mod z equal to 3. We found z equal to 2 is the singular point. In the case of example 1, it lies outside. But in the case of example 2, z equal to 2 is a singular point, lies inside C. And then we assume capital I as the given question for both the problems. At step 2, we checked the denominator and we found the singular point lying outside and lying inside respectively for example 1 and 2. Next we deal with the numerator. We know that e power minus z is an entire function. So e power minus z is analytic inside and on C. Next, it is very important how you choose the function f of z. In first example, numerator is analytic. In denominator, we have z minus 2. Since z equal to 2 is the singular point, lies outside C, so it will not affect the problem. So I am taking f of z as e power minus z divided by z minus 2. And this function is going to be analytic inside and on C. So I choose f of z like this. But when you come to the case of example 2, z equal to 2 lies inside C. So the singular point is lying inside the region. When I choose f of z, I should choose it very careful. I can choose e power minus z because it is analytic inside and on C. I cannot choose this z minus 2 because z equal to 2 is the singular point lying inside C. At z equal to 2, the function is not analytic. So the only option I have to choose f of z is equal to e power minus z. So in this problem, at example 1, my f of z is whole question. So I can write this as integral c f of z dz. Then immediately I can apply Cauchy integral theorem and I will tell the answer is 0. But in the case of example 2, my numerator is f of z, denominator remains same. Now by Cauchy integral formula, comparing the results, I can write this as 2 pi I into f of 2 because Cauchy integral formula says integral over c f of z divided by z minus a dz is 2 pi I into f of a. Now you can see the typed version. So how you choose your f of z is very important. When you choose your f of z, it should be always analytic inside and on C. If you remember this, you can easily crack all the problems. Next, let us see one more problem. Integral over C z divided by z minus 1 whole cube dz. Given region is mod z equal to 2. It is a circle with radius 2. My singular point is 1. Obviously, it is going to lie inside the circle. And the important thing, it is of, we see the denominator, that is z minus 1 whole cube dz. Therefore, singularities with higher order. Then we have to apply Cauchy integral formula for step 1. Sketch the region. Given region is mod z equal to 2, which is a circle with center 0, 0, radius 2. Now we can draw the circle and sketch the region. Next we have to find the singular point, that is my step 2. When we equate the denominator to 0, we get z minus 1 equal to 0, that is z equal to 1. Z equal to 1 means the point is 1, 0, but the circle with radius r equal to 2, therefore the point 1, 0 lies inside C. Next step 3. Since z equal to 1 is a singular point that lies inside C, next we have to assume capital I as my given question. Now we have to deal with numerator. Numerator we have z. It is a polynomial. Z is an entire function. It is analytic everywhere inside and on C. But when you see the denominator, we have z minus 1 whole cube. It has singularities as well as it lies inside C. So I cannot take this as f of z. We have to take f of z very careful. So I'll take f of z as z. Therefore, f of z is analytic everywhere, that is inside on C. Now it is very obvious we have to apply Cauchy integral formula for higher derivatives. And here in the denominator, we have 1 by z minus 1 whole cube. So we have to think like this. 1 by z minus 1 whole power 2 plus 1. Therefore, my n value is 2. So my capital I is going to be simply 0. This is my answer. With this 3 problem, basically we understand how to choose either Cauchy integral theorem or Cauchy integral formula or Cauchy integral formula for derivatives. This gives a clear roadmap to solve the problem, but there are some questions left to you. See this example. The denominator consists of two terms, z minus 1 and z minus 2, and the region is mod z is equal to 3 by 2, that is 1.5. So this is the circle with radius 1.5. So we have two singular points now. Z equal to 1 is the singular point lying inside because the radius is 1.5, and z equal to 2 is the singular point lying outside C. So in this case, how to solve the problem? Because in this case, I cannot apply either Cauchy integral theorem or Cauchy integral formula. We are going to deal such problems in part 2 video. Meet you there. Hope you understand.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.